In last video we had discussed about the thrust and the pressure, and now we know the difference between them. In this particular video we'll discuss about, first of all we'll discuss about the pressure in fluids. You should know what is the meaning of the fluids. Fluids means all liquid and the gases are the fluids. Okay, means all types of gases and the liquids, that is which can flow, which has the property to flow or to occupy the shape of the container, is known as the fluids. Okay, so pressure in the fluids means, when just you try to understand the pressure, as we already discussed, the pressure is the thrust upon area. Pressure is the thrust upon area. So in the same way we can understand, when a fluid, that is a liquid or gas, filled in a container, it will exert a force. It will exert the force on the bottom of the container. So that force, perpendicular force, acting on the surface, perpendicular force, okay, it should be 90 degree. So this thrust, that is the perpendicular force per unit area, is called the pressure in the fluids. Okay, in the same way, when a solid placed on a surface, it will also exert a force on the surface due to its gravitational force, due to its weight, and that weight produces the pressure on the surface. So I think it is clear. The pressure means, the pressure is the perpendicular force exerted by the gas, liquid or the solid on the surface. So that is the pressure in the fluids. Now we should also know what is the difference between the pressure in the fluids and the buoyancy. Okay, buoyancy means actually this pressure, already we had discussed about the thrust, that is the downward force generally we consider, and the buoyancy is the upthrust force. It is also known as the upthrust. So I think it is clear by the name, that is the thrust, that is a force upon area in upward direction. Upthrust. Okay, see the example. Suppose you try to dive in a water, so water will exert a force in upward direction. Okay, that is the paper boat floats only due to the upthrust. Balloons can move in upward direction only due to the upthrust exerted by the air. Okay, so that is the buoyancy. So buoyancy or the upthrust, it is the force in upward direction. Now question arises, why buoyancy exert a force in upward direction? Because it is just like the reaction of the downward force. Because when something placed on the water surface, and then water surface in reaction will exert a force in upward direction. Okay, so this is the upthrust. Now we can understand, when we placed a solid on the surface of the water, why it floats, why it sinks. Okay, why it sinks or why it floats. So dear students, you should understand by a simple diagram. Suppose I am taking three conditions. Okay, three conditions, 1, 2 and the 3 condition. Suppose this is a body which is to immersed in the liquid. Here the liquid is filled. Suppose water is filled here. So when we suppose this is a solid, so its gravitational force, that is the weight is acting, will be downward direction. So when we place here, suppose it is placed here, so weight will work in downward direction and the upthrust will work in opposite direction. So when W, that is the weight, is greater than the upthrust, when the downward force acting per unit area, suppose it is the more downward is more than the upward, in what will happen? Resultant is always in the direction of the greater, that is the body will, in this case, will float. Okay, so here in this case, especially I am taking this case, suppose the weight is more, it means the body will go inside. Okay, and it will rest in the bottom. It means you can say the body will sink. It will sink. Okay, it will come downward direction because resultant is working in downward direction. W is greater, na? It is greater. So body will come with greater force downward direction, and the body will come here and the body will sink. I think it is clear, the first case. Now see the second case. Suppose the both are equal. W and W dash. Both are equal. Okay, it is equal. Then what will happen? What will happen? It will take its place inside the water. The solid will take its place, its volume inside the water. The level of the water will raise and the body will float. Body will float. So it will float. It will float and fully immersed. In this case, it is the fully immersed. Okay, it will float. It will not sink. Okay, it will not go in the bottom, to the bottom of the container. It will immerse fully, but it will float also because both are equal, both are balanced. So the resultant force on the solid will be 0 in this case. Now dear students, see the next case, interesting case. Suppose the weight is less than the upward force. Okay, upward force, suppose W dash is greater and W is less. Then what will happen? You know the resultant is always will act in greater direction. Greater direction, na? Students, suppose you are applying the 12 Newton force in one direction and someone is applying the force 50 Newton. Then what will happen? The resultant kidhar hoga? What will be the resultant direction? It is the 50 minus 12. It is always towards in the direction of the greater force. So in the same case, we can see here the resultant will act in upper direction. So body, in this case, body will float. Body will float. A body will float, but it will not immerse. Body will not immerse, and on the surface of the water, the body will float. So in different terms of the density, we can understand if the density, because see, weight kya hota? What is the weight? Weight is equal to m into g. Okay, and mass means volume into density. Because density is equal to mass upon volume, na? So mass is equal to density into volume. Okay, so density and the g is constant in this case. Okay, so it means if the density is more, it means the weight will be more. Okay, so here we can apply the same condition. If the density of the solid is more than the density of the liquid, density of the water, then the body will float. So dear friends, what is the conclusion finally? Therefore you can say the objects of density less than that of a liquid float on the liquid. Okay, liquid. And in the same way you can say, and the just opposite condition, the condition to sink, that is, you can say the objects of density greater than that of a liquid sink in the liquid. Okay, so in simple case you can say, that is the density of the, suppose the solid, if it is greater than the density of the water, then in that case body will sink. Okay, what I written. Okay, if the density of the solid is greater than the density than the density of the water, body will sink. Okay, body will sink. And if the density of the liquid or the water is greater, in that case the body will float. Okay, so what I have written, just try to remember, try to understand. If the density is more of this solid, then the body will immerse. If that is a sink, if the density of the solid is less, it will float. So this is the condition of the flotation also. So after this topic, in the next video, we'll discuss about the Archimedes principle, which is very, very important for your exam. Thank you, students.